Howdy folks! Alrighty. So I'm back after a little while. I've been kind of MIA, but I'm back. I got this thing now. This tutorial we're gonna do. So yeah, what do I need to say first? I didn't set up a script. But so what the plan is I'm gonna be doing this live stream. It's gonna be like a complete breakdown, like the whole thought process and all that stuff. And then later on, I'll be doing a video, which is just gonna be like a spliced up, edited version of this live stream. It'll be much shorter, and it'll just kind of be just what you need. You know, it's not gonna have all the thought process stuff. But we're just doing the Z targeting thing. There's nothing else that's gonna be going on. I don't know if I have any other notes. So I guess we're just gonna get right into it. Alright, so first off, what you're gonna need is a scene. You know, like I hope you have, you know, your stuff exactly. Get your ducks in a row. You know, I'm not gonna be showing you how to like do a character controller or enemy AI or anything like that. It's just gonna be the Z targeting stuff, and specifically, I'm going for an Ocarina of Time movement, but Breath of the Wild's kind of camera. You know, so it's like a free moving camera. You can move, well, in Breath of the Wild it's a joystick, but with the mouse here. But the, you know, like Zelda's Z targeting system is, it's not what I thought it was. So, what I used to think it was, I'll try to simulate it here, because I don't have the system set up yet, is basically the camera is locked to the enemy, and then it's just stuck on the enemy, and you basically rotate around him, you know? So you just kind of walk around the enemy. But no, what it is your movement is still completely free. You know, like you press L, well, you go left, that's right. You go left, and you're gonna go left, whether you're looking at the enemy or not. So imagine this is the camera is facing the enemy. You're gonna go left either way. That's basically how Ocarina of Time did it. And that's how Breath of the Wild does it. Weirdly, Tears of the Kingdom does not do it. Tears of the Kingdom does this. I don't know why there's a difference there. But, you know, like, because Breath of the Wild, well, in Zelda games and Nintendo games in general, they have it so when you're walking left or right, you rotate around the camera. But in Breath of the Wild, it's like that when you like don't mess with the camera. So if you don't move the camera at all, you'll rotate around the camera. And I'm just trying to simulate it right now. This isn't like perfect or anything. I'm just trying to simulate it. When you don't move the C stick, I guess, you would normally rotate around the camera. And in Breath of the Wild, how it does it is if you don't move the C stick when you Z target, you'll rotate around the enemy. But once you do move the C stick, you'll be able to move freely, you know, like this. So we're only going to be focusing on this right now, just because I don't want to do the state transition work. If you want the version where you are locked onto the enemy and you're moving around like this, That's in a previous live stream. If I here, I'll pull it up. Here, let me. I'm gonna plug myself here shamelessly. Let me figure out which live stream it is. Just 1 second. Well, it's the last live stream we did, so it's this one here. It's the last live stream I did. This one. So if you want that version of the Z targeting system, watch this video. It's somewhere in there, I promise. All right. You'll have to find it, but it's there. But anyways, oh, whoops, no, I actually don't want to close that. So, yeah, now that I got that out of the way, what I'm doing, I suppose we can get started. So, here is what you need ahead of time. You need to have your character controller set up, you know, so you have to have your movement, you gotta have your camera set up. If you want to, like, pause it and look at this stuff, I'll give you a second too. This stuff right here is, you don't need to worry about this stuff. That's not your problem. That's my problem. Yeah, there's the player stuff. Here is the camera stuff. And so, yeah, that's, you can pause that, go back. If you don't have that stuff out, that's not in the scope of this tutorial. But what you're gonna need otherwise, obviously, is a character model. And specifically for this, all you're gonna need for animations, you don't really need animations anyway. But all you're gonna need for animations is a run and back, strafe left and strafe right. So I'll play these for you. This one is run back. Here's strafe left. These are kind of goofy looking, but oh well. Here's strafe right. And you can do 8-directional one if you want to, but that's I'm too lazy to do that. Anyway, you're also gonna need animation tree. So make sure you have an animation tree, hook it up to your player mesh. You know, this is just what I have for now. The idle animation, run animation, and then I changed the speed because I thought it looked nicer. And so for in the animation node, this little thing here, this animation tree node, you're gonna wanna set it to, what is it? Blend tree, right? Yeah, I think I set it to blend tree. Yeah, blend tree. You're gonna want a blend tree. I don't know the names of these. And within the blend tree, I have this just set up so it's a run blend. So there's idle on the in, and then just running in the blend here. And so that's what this is for. So I have animation or animation tree or anim. That's set, parameters, run, blend about, and this is what I have here for what I got earlier. That movement, if you thought it was nice, because I thought it was nice, is you know, yeah. I'm gonna move this as low as I can. That. But yeah, I have the move vector turned into a float, divide that by speed, clamp it to between 0 and 1. And so that's what that is. Anyways, what's this here? Oh, I know, that was when I was trying to experiment with IK. Okay. So let's just you gotta get a blend space 2D. And in the blend I feel like I'm acting like I never used this before. And so in here you're gonna wanna get your animation set up for your targeting. So run back, strafe left, and strafe right. You're gonna wanna set it up like this. Strafe left and strafe right usually are gonna be on the Y axis right here. Well, strafe left and strafe right are not bleh. Strafe not strafing. Run and run backwards is gonna be the wait, no, this is the Y axis, this is the X axis. This is run and run back, but I don't know if I have them backwards, so we're just gonna do with this for now. And then same thing with strafe left and strafe right. I don't know if I have them backwards because I don't pay attention enough. But strafe left and strafe right, they are on the X axis like this. So now that I have that broken down, we are going to start with setting up the actual system here. So first what we're going to do is we're going to use an area. So I'm going to add an area node. I'm just going to collapse these here. Make sure this is cam. So this is an area, and then I'm going to add a collision shape. You can make the collision shape whatever you feels right. You can make your own collision shape if you want to. I am going to do a sphere, make it a little bigger, and then just move it like this. This I think is the most cone-like you can get for now. Well, in Blender by default, not Blender, Godot by default. I don't think, yeah, no, there isn't any cone collision shape. There is a height map collision shape, but there's no cone collision shape, which is weird. Anyways, so there's that. Why is this rotated? So there's that, and then here. All we're gonna want to start with here is check if a body has entered. So we're gonna put on body entered in the player script or whatever script you feel. As long as it's connected to the player, obviously, or has something to do with the targeting system. And what we're gonna do is we're just gonna do, I don't know, if, hang on, what is it? If body dot is in group, and we're gonna figure out a group. I'm gonna targetable. Oops. And so in the enemy here, I'm gonna make this targetable thing. We're gonna add a group, targetable, and we get global one. Sure, add our description, anything the player can target. So we're gonna do that. Also, within the enemy, I don't have a script for the enemy yet. I'm going to add what is it? A marker 3D. It can be a node 3D too, but a marker is just specialized for this. We're gonna add a marker 3D and target point. And we're gonna give this an area, I think. I'm gonna try something, collision shape. Actually, you know what? Yeah, no, that's fine. Let's do this. This is okay. This is... No, we're gonna call this target point. Screw that. We don't need a marker. We need this. This is all we need. And what I'm gonna do is, well, first let's do this. Print object in range. Huge. Oh well. But you see object in range right there. So if I pull away, object in range, pull away again, object in range, pull away again, object in range. There you go. You see what I'm doing. I want to lower this. This pulls up for some reason on its own. I want to see. Okay, so maybe that's a little small. No, you know what? That's fine. That's a fine size. I don't know. You can make, again, you can make the area whatever you want. But, yeah. On top of that, we are also going to add to the camera, or we can do the spring arm, or no, we can add it to this. We'll add it to this because, yeah, we'll add it to this ray cast. No, we're going to add it to camera. That's what we're going to do because of stuff we're going to do later. I don't know. Set it to whatever distance feels right. I'm going to set it to 10. This is specifically for if a target has, well, if something has multiple targets. That's what this raycast is for. Well, no. It's also going to be for determining which object you want. We'll figure it out. The target you want to target it'll be the one right there. I'm very eloquent. And so run the project for no reason. Maybe set a specific collision layer for enemies. Where is it? Where is collision layers? Render 3D physics. We're gonna do world. World there. We're gonna do layer. Let's do enemy collisions. I don't know. Enemy. We're gonna do enemy for 5. That's what we're gonna do. So we are going to put enemy on layer 5. We're going to set this specifically to layer 5. Yeah. And let's do that too, just in case. So here is the neat part now. Now I have to check my older code to figure out how to use a dictionary again. Okay. All right, so we're also another thing we want to do. I don't know. What we are going to do now is we're going to get a dictionary, and we are going to get targetable bodies. Dictionary. And I wonder if I did anything specific up here. Nope. I didn't. And so cannot assign a value. Why? Okay. Oh, there we go. Alright, if body dot is in group targetable, what we're gonna do is in this on area 3D body entered, what we're gonna do is we're gonna target the both bodies, body dot get instance ID equals body. And then what we're going to do, we're gonna go back to signals. We're gonna do on body exit, and in here what we're gonna want to do is var ID equals body dot get instance ID if ID in targetable bodies targetable bodies dot erase ID. And then here's what we're going to do. We are going to print and do print body has entered plus string body. And then we're going to print body as left. String body. There we go. Oh, nope, don't do that. So body has entered, body has left. Body has entered, body has left. Body has entered, body has left. Entered, left, entered, left. We don't need this. We don't need the raycast. I've realized here. Let me open this. Nope. From here, we're going to create a function, and we're going to say, call it func get nearest nearest target. We're gonna do pass for now. And we are going to set up a target button. So I'm going to do this target. Do whatever you want as long as you remember it. Just set it to middle mouse button. And we are going to do for body in targetable bodies. How did I do this again? I'm trying to figure out how I did this. Ow. I just hurt my brain. How did I do this? I do not remember. Alright, targetable. Ah, here I see. So, our closest target equals no, and our distance equals in, which is short for infinity, of course. Dot values. Var distance equals global position dot distance to all position. Oh, there's already target distance. I didn't know there was something called distance. Hello. Where's distance? Where's target distance? Oh, wait a minute. Duh. I'm a little slow. It was named right here. And then if distance greater than closest distance, closest distance equals, wait, no, it's going to be nearest, so it's nearest Oh wait. I need to make this closest distance. Far distance. Closest. Closed. Closest. There we go. So if distance is greater than, oh no, less than closest distance. Closest. Okay, thank you. Alright. Closest distance equals distance. Closest. Nope. Nearest equals body. And then we need to return nearest. And so there you go. That is how you get all of these things. Whoops, nope. That's how you get the distance to the target that output you were looking for. So now what we are going to do is in your process or physics process script or input script, I guess you can do that too. Well, input script is a bit different, but we're going to do if is input dot is action. Wait, no. If input dot is action just pressed target. Actually, I forgot what I needed to do. Before that was I needed to create, oops. I need to create a target. So I gotta set that to null. So if is just press, if is action just press target. And what we're gonna do if target, we need to call get target. Get target. Water nearest. But no, if not target. Nearest target equals get nearest target. And then what do I need to do? Blanking on what I need to do. Test unit. Oh. Oh man. I just found a tick on the back of my neck. No wonder I've been having a headache. I'm gonna die soon. Can I kill it with this? Oh yeah. Ooh, wow. That's interesting. Now I feel gross because I just pulled a tick out of the side of my head. That's wonderful. Well, it's dead now. I just stabbed it with a pencil. Alrighty. Okay, what was I doing again? That's right, this. Right, I'm trying to figure out. Thank you. Neat. I am trying to figure out how I get if parent to target. Blah, blah, blah. Elf, our target is parent, not target. It's target. How in this do I hit target? Okay, so I guess, okay. Okay, here's what we're gonna do. So, if input is action just pressed, target, target equals nearest target. And then, here's what we're going to do next. It's crazy. We're going to do an enumerator. And we are going to get enum normal, I suppose, or free. We're going to call it free. Target. And you can add these to your enumerator, or your if you already have a state machine built in, you can just add these to it, because we are going to create a new variable, and if you already have a state machine like this, you still create a new variable. It is called our, what is it? Target state equals free. And so, in your state machine here, wait. Oh, wait. No, wait. Yeah, wait. Oh. Don't be messing with me, you stupid thing. It's a stupid thing. Let me move this down here. Let me move these back down again. What did I do? Where did I go? I forgot what I was doing. Man, that tick really sucked a lot of blood out of me or something. I just lost my mind. I must be losing my mind. Match. Target state. Free pass target pass. So in this state you can kind of do whatever you need to do, or in this little thing. So in free, well, the first thing we're going to do in target is we are going to, oh wait, hang on, wait, let's do this in here actually. Process. So this is, we are going to do free here. I can just leave these. We can set this here. And then here, mesh dot rotation dot y. No wait, no. Mesh dot look at vector 3. Target dot global. We gotta get an enemy script over here. Enemy. Already var. Target. And we're gonna make that equal to target point. Just for now. Let's call this target point dot global position dot x Y, because we don't want the player. We don't want the player looking at the, because the player's root is right here. We don't want it looking at the Y position of that node, because why it would. Well, I'll just show you why. Y, Z. I wonder if this will just work. It probably won't, but I wonder if it does. If target state equals target tab bar, no. Target. Nope, I don't want to run that. I want to run this. Nope, I want to run that. So I wonder if I just do that. Yeah, see, the player looks at target point, which is the area around the head of the target. See? But hey, we're like basically halfway there. And how far are we into this live stream? An hour. About an hour. Almost an hour. 40 minutes. So yeah, we want to look at players position now. Y. Nope. This. So there we go. Now the player is looking in the direction of the enemy, which in this case is a man who is like, I don't know, almost 6 feet tall. No, not almost 6 feet tall. Well over 6 feet tall. Because the player right here I know is 5'7". Very close. Uncomfortably close. Anyways. Yeah. Target, don't look at. There we go. And then here is where things get weird. We want to look at the camera spring arm. On ready bar spring arm equals spring arm, and we also want to look at the cam root. On ready bar cam root equals cam root. And now we aren't gonna be doing that weird unhandled inputs or unhandled screen space position thing, because Breath of the Wild and Tears of the Kingdom don't do that either. They don't do that unhandled screen space input, whatever it is called, thing. What they do is way simpler, and I didn't even know. So it's kind of like stupid how basic it is. But here, let me just let me. I don't know what the code what their specific code that they have is, but I know for this project right here, or this is how you execute like the same exact thing in Godot. So, what is it? There we go. Alright, so we just gotta do this, except it's cam root. Just cam root global position equals vector 3 global position x y C, and then we're gonna except what we're gonna do is we're gonna do target point at global position, and then we're gonna divide that by 2, and that'll get the halfway point between our two objects. So right now it's just gonna look weird, but we're close. We're close. You see, but when you walk off, the player walks off the screen, enemy walks off the screen. So that's weird. But what next you gotta do is it's again stupid easy. Spring arm, spring length, global position, distance to cam, global, wait, what? No, yeah, cam root, global position. And what this does is this basically, you know, gets the, what this does is this gets the distance from the player and the camera. So from the distance from the player to the camera, or you could do it if you wanted to. You could get the distance from the target to the camera. But either way, it's the halfway point. You know, it's the same thing. And this number is 1.7. But for this specific project, we have it a bit wider. But this is like the spring. Actually, no. You know what? Actually, I think that's good. 1.7. Yeah, no, that's good. So I multiply it by 1.7, and here's what you get. There you go. And the player will always stay on screen with that specific variable, unless it's like this, where it's colliding with the ground. But in that case, I don't know. Do what you want. Oh, you can see the LOD of the auto-generated LOD of the player right there. The hair mesh kind of just clips. At least I can. I don't know if you can. But so yeah, that works. And then if you want to, you can set a limit if you really want to. If you say if global position dot distance to target dot global position target position target point dot length is greater than I don't know, 20, let's say 20 meters. Then target state equals target state equals, what am I saying? Target state equals free, and then we're gonna get you can hard code. I'm just gonna hard code these positions. You don't have to do that. You can, but what I'm doing right here is once it you know what, no, let's not do that here. Oh wait, no, it's gotta be dot length. So it's going to do something weird, I know. So, but we're going to look at the enemy, and then once we get far enough away, seems like a pretty far distance. There's no way 20 meters is that long. Is 20 meters that long? Okay, we're gonna make it 5 meters. Yeah, no, that's well over 5 meters. We have low position, the direction to. Maybe distance to. Yeah, distance to. I don't want direction to, I want distance to. Sorry, I got mixed up there. Distance to. Whoa. Target point. Huh? Why is that that's not an integer. There we go. Cool. Invalid access property. Target point on base int. Okay, if I delete all that, then will it still be doing that? It shouldn't be. Okay. Okay, there we go. That was weird. But if it exceeds 20 meters... What? Oh, I know what's going on here. I know what I was doing. Now I know what I did wrong. Target state equals free. Target equals null. Got that done. There we go. And then now after 20 meters, it unlocks, and we got a Shadow of the Colossus thing going on there. Very dramatic and dynamic. So here, what we're actually going to do is create a function. We're going to call it end target. And this is going to be void, I know. It's not going to return anything. It's not supposed to return anything. So we're going to do end target. So first we're going to do target equals null. And here I'm going to hard code stuff. So I'm going to do create tween var tween equals create tween dot tween properties We're gonna do cam root is global position. We're gonna do 3, 0, 1, 2, 0. And then I'm going to set it to 1.0.2. That's what I'm going to do. And I think we're just going to do position. Camera position. We'll call that between 1. And it's going to be between 2. Nope. And this is going to be spring arm, spring length, we're going to make this a bit longer, and this is a float. It's 3, right? I set it to 3. Yep, 3. So 1. Yeah, I think that's good. And then target state equals 3. So here we're just gonna do end target, and then also do else end target. That, and then there we go. But those are linear and those are ugly on linear. And then dot set trans sign. And do the same thing here. That's a sine as in sine wave, which is, you know, there we go. See? Pretty. Except I'm gonna make this, I'm gonna make that a bit slower. Okay, I'll just make that the same speed. Maybe we'll make them both 3. What if we make them trans bounce? That'd be fun. We'll make this a bit longer. 6.6. And this is just filling with this. Oh no, we really don't want that. So, trans elastic. Maybe let's do that. Oops. No, we don't want that. I don't know. Spring. Nope. No. Okay, let's just back? I don't know. I'm just messing around at this point. Sure. Well, that does a weird thing. Quadratic. There we go. Let's just do that. I'm gonna make this larger. On that, just so we don't have that weird bugging. And then, all right, and now there's only one more thing we have to do, and it's really the only complicated part. Even though it's not really complicated, it's just kind of lame. If I can figure out where it is. Ah, yes. So here is the only borderline complicated part. And it's not even that complicated. It's just a little bit of map. And I'm just going to copy and paste it because I'm lazy. So in the targeting state, we're just gonna do this, which is this, but here. Wait, no, it's not that, but here. This is actually to get the relative direction in the target state, or in the mesh. So the mesh is looking in the, here, actually, I'll just show you what it does without it. So, let's do this. We're just gonna do this because it's cheap and easy. There's normal run, and then there's target blend space, and we are going to target blend. That's what we're gonna do. Targ. No. Anim dot set. We're going to targ blend. Excuse me. 1. So right here, so if we just do something like target blend, or we're gonna target blend space, we're gonna get, if we just do, here, let's target blend space, and we just set to direction dot x, direction dot z. Oh wait, vector. if we just do that, if we just do direction, something weird is gonna happen where I don't know if you see what's happening right here, but it's the animations are not in the right direction, basically. It's acting weird, and these are backwards. But this is going forwards, and this is moving backwards. But that, I think these are all backwards. Okay. Well, we'll figure it out. But if we do this, if we have this right here, meshter, suddenly the animations are right for the direction that they're going, except for the moving backwards, because these are, well, the moving backwards and forwards, because I got these backwards, as I thought I did. So, I'm just going to go back in here, I'm going to move this, we're just going to flip-flop these, and there you go. There you go. And I think that, is that it? Did I do it? I think I think that's it. I don't know. But you disconnect, you can reconnect. I don't know, maybe I can tween into that position. But just to show you it's not like a scam or anything, we can just do, I can show you it'll work where the enemy is moving. Physics process delta. What do you do? Velocity equals vector 3, 0, 0, 1. Wait, no. And then move and slide. I'm too lazy to just add AI, so we're just gonna do this. Oh, he's gone. He's Sonic. He's actually Sonic the Hedgehog. 0 times delta. That's probably the issue because it was in speed in frames. But see, camera follows once he leaves range. There you go. He's gone. Gone with the wind. No. I wonder if I just do that. I don't know. I really think that's it. I don't know. Is there anything else anyone wants to know? Because I think that's it. Oh, yeah, that's right. The area here. Here, let's do a thing where we figure out. Well, actually, here I'll add a few more enemies here just to show it's not a scam in that sense either. But yeah, it just gets the nearest enemy, so it doesn't get. Here. Let's make this a nicer transition. At least, the least I could do is make it a nicer transition. If not target, let's do function start target. Start target. And so I'm just going to do start target. Wait, hang on. We're gonna return nearest. If nearest target, then we're gonna do target is nearest, or actually start target. We're gonna do nearest target. Nearest target bar target equals nearest target. And then here is what we're going to do. No way. I don't know. What you could do is just get wait, no, I can do this. We can do tween bar tween one again equals 3 tween, and then we can do tween one dot tween property cam root position final variable and now this is gonna make it a little draggier. Let's restart the music. There we go. It's gonna be 0.2. Two dot tweet drop spring arm. Nope. Spring arm. Spring. Can you, like, yeah. Spring length, spring arm, spring length. So, in the way. 2. And then we're just going to do That's weird. That broke. That's broken. Yeah, that's broken. I don't like that. So I guess we're not going to do that. We gonna keep it real, folk. That was so dumb. There we go. So I'm gonna. I think I can leave it at that, right? We officially have C targeting. Now the algorithm in which we determine which enemy we're targeting is very minimal, but it works. You can add UI onto this, and it'll be great. Here, let's turn off visible collision shapes. Oops. All right. All right. Well, there you are, guys. There's C targeting for you. Hope you enjoyed. Let's see if I missed anything from. Nope, I didn't. Okay. Hope you guys enjoyed the live stream. I will do my best to edit this into a much shorter video at a later date. Thank you for watching, and I'll see y'all. Well, I gotta. Oops. Sneaky. I'll see you guys next time.